All right. They're called rational functions. The reason they're called rational is because there is some ratio involved. In other words, a fraction. But for it to technically be rational, there has to be a variable in the denominator. So you look at our first example, we're talking about 1 over x, correct? You had to graph that one already, right? Is there a variable in the denominator? Yeah. Is there any way I can get that variable to go away, like cross off like you were doing on the worksheet for today? There's no way to simplify it and make it go away, is there? And so that's going to be there. So this is rational. This word right here is probably a new vocabulary word for a lot of you. Asymptotes. Those little dashed lines that were in that problem that I had over here, those are the asymptotes. They are little lines that kind of draw the graph towards it, is what they really do. And I got to be careful how I say that because sometimes the rules are broken, but it does draw the graph towards it. Let's put it that way. And here, if we take a look at this one, just trust me, the asymptotes are at x equals 0, which is, whoops, helps if you don't have that on. It should work now, right? There we go. There it is, and there it is. X equals 0 is the one that's vertical. Y equals 0 is the one that's horizontal. It's understood that dashed lines are asymptotes. Okay? That's as understood in any rational graph. Okay? So this one only has 2. And remember all those points you had to get if you actually graphed that one accurately the day I gave you the parent graphs and said, here, graph these. It took a lot, right? But when you put in, you did your XY table, when you put in 1, right, you got 1. And when you put in, a half, you got 2. And when you put in 2, you got a half. And so the graph kind of did something like this. Agreed? Because I think this is the one where I talked about what if you put in 1/10? It's 1 over 1/10. So it becomes 10, right? So if you're at 1/10, it goes way up to 10. And then where was the other part of this graph? Do you remember where that ended up? Where did this parent graph, where did the other part end up? There's a second part. Yeah, it was down over here, right? And basically you could just call this the third quadrant portion of it, right? Does anything graph in the fourth quadrant for this one? Nope. Does anything graph in the second quadrant for this parent graph? No. Remember, you had to get a bunch of points to find out where those were. Now that you see the asymptotes, do you see what I'm talking about? It kind of starts at this point here, and as x tries to go that way, do you see how the asymptote pulls the graph down, pulls it closer? And as x gets smaller going this way, again, that asymptote kind of pulls that graph in there. Same thing. It pulls it towards that line, pulls it towards that line. Okay. So that's our parent graph. Now, how did we move all those other ones? Like, for example, when we had x squared, remember we moved it all over the place, right? When we had x squared like this, and which point did we try and move when we did that? We always tried to move 0, 0, right? To move this particular parent graph, what we're going to do is move the asymptotes and then put the graph in. Okay? So that's how we're going to translate it. So what does this do? Well, you have to decide, is that +1, is that inside the function or outside? That's the tough question here. Is it inside or outside the function? Anybody want to take a stab at that one? Inside or outside? Yes. It is inside. Very good. Because outside would be something like this, +1. All right? So it is inside. And inside is either it moves it right or left, correct? But this one, it's opposite of what you think then. So we're going to move this left. How far? 1. So to move it left 1, does this one right here, does this one get moved, this horizontal one, if I'm moving left 1? Can you really move that left 1? Not really. So that one stays. It's right there, right? That one doesn't get moved. If you really want to, I can move it left 1, but it's still the same graph, right? It's still in the same spot. Can the vertical one get moved left 1? Most definitely. So it should be over here, right? You agree with that? Now, did we do any reflecting from that parent graph? According to what you see written here, should I reflect it? Should I do any more moving of that graph? Or is this it? That's it. So where did it? It was kind of top right is where it was before, right? So put it in the same spot. Top right, here it goes. And again, these can just be sketches. Is that it? Well, no, there's that other part, right? So here's the question. Should this second part go all the way to that y-axis? Should it go across? No, the asymptote cuts it off, right? So it's just like that. Well, that's not that hard, is it? a new vocabulary word for you, but okay. Any questions on how we moved that one? How we decided that that would be left 1, right? All right. How about this one? Moved left? Do I move this one left 3 or something? Right 3 then? Up 3? Down 3? I don't know. That 3 is kind of in a tricky spot, isn't it? Isn't that kind of 3 times what I had before? So what does that do again? Does that move up, down, right, left? No. So your asymptotes don't move. What that does to your y values is make them kind of 3 times what they were before. And in your parent graph, I believe that was the y value, correct? So it makes it 3 times bigger than it was before, so now it's up at 3. So what it does is it just kind of pushes it away. Obviously, I exaggerated so you can see it. It pushes it away from the asymptotes a little bit. That's all. So what do you suppose, say, like a 1/3 would do then? Yeah, it pulls it even closer, which is kind of hard to believe, but it pulls it even closer. And that 3 would have to be down on the denominator, okay? For that 1/3 idea. So this was just a dilation. Ooh, a lot of stuff happening here. Does anybody think they can tell me? I'd say there's 3 things that happen here. Raise your hand if you think you can tell me just one of them. Any of the transformations that happen here. Yeah. Yeah, that 2 is going to dilate it, right? We'll make it bigger. Should we just say, is bigger good enough for you? You understand what that means? Okay. So bigger. It's not probably the most technical term in the world, but makes sense, right? If you at least know what we're talking about. So that's 1. Check. I agree. Anything else that's going to happen? I heard somebody say it. Up 3 is correct because of this. It's outside, right? So up 3. And there's one more thing that's going to happen here. It's going to get flipped. There you go. Or what's the technical, more technical, is reflected. Over what? The x-axis. And really, with this graph, does it matter? Isn't the reflecting over the x and y the same thing? It doesn't really matter with this graph. All right, so we've got to move this thing up 3, huh? So then that's the one that you can actually move up 3, right? The other one you can't really move up 3. So the other one doesn't move then? Yeah, that one just stays. Stays right there. And, okay, we were told bigger and then reflected. Okay. So should I graph up here on the top right somewhere then? Should I graph up here? No, because this part that was up on the top right has now going kind of on the bottom right? So, and just kind of bring it away from your axis a little bit. Do you notice, am I sitting here figuring out a bunch of points when I do this? No, I want these to be sketches. I want you to say, hey, yeah, that's right about there. Good enough. And I almost want you to exaggerate those dilations so you show me you know what's happening. All right. And then should I put some down here on the bottom left then? Is that where I should go? No, that part got reflected up, right? So again, you know, it's kind of exaggerated there a little bit and say, I got pushed away a little bit. Any questions as to which piece? So which piece up there reflected it, by the way? Yeah, that negative out front, right? That's the one that reflected it. Okay. All right. Why don't you give that one a whirl all on your own? All right, so let's take a look. Did anything happen, or is this just the parent graph? some stuff happened. I'd say, how many things happened this time? 2. And let's see here. Who thinks they can give me one of the 2 things that happened? Yes. This one did not get flipped. No. Bigger by 1, I guess you could say that, but 1 would be the same, right? If you get bigger by 1, yeah. Right 4, are you sure? Yep, because it's inside, and it's the opposite. Yes. Down 2. Why is down 2? Because there's outside, so it moves it down 2. But again, what really is the easiest thing to move? It's not the only thing that gets moved, but it's the easiest thing to put on there are the asymptotes. So down 2, right 4. Was there a reflection? No. Dilation? Not really. I mean, it's just times 1. So it's the same deal. And so it'd be somewhere, something like this. Up there, and now this is the hard one for some people because there's so many lines right here in the middle. You got your x-axis, your y-axis, and all these asymptotes everywhere. But what you do is you just go ahead and you put it down here. Follow the asymptotes. Kind of erase the x and y-axis in your mind at that point. They're not there anymore. Okay, they are, but you just need to get that away. Question? Okay, because that's the inside. It's right or left, and it's always going to be the opposite of what you think on those when it's inside. Always opposite.
That's pretty easy.
Do you have a question? Were you good with the transformations before now? Like up to, left 4, could you do those?
You're dull.
Okay. Well, there is always the option of always doing an XY table for everyone. Or studying to figure it out. All right. So that one, that's moving a parent graph. This is going to be slightly different, but this is also why we did some of the stuff we did in that worksheet. You should always do this first. Whenever I give you a rational function, what does that mean again? It's a ratio, so you need what? Fraction, okay. What more specifically? So here's where your note-taking's got to get a whole lot better for the next level. I said it once. You should have it down. That's how your professors are going to feel. An x or a variable in the denominator. Okay, that's what makes it a rational function. Does this have a variable in the denominator? Yes, it does. Now, whenever you have that, there are going to be some types of discontinuities. Maybe it's going to be an asymptote. Maybe, like you just learned what an asymptote was. And maybe it's going to be a hole. First thing you need to do is figure and look for any possible holes. And you do that by taking a look, can I factor any part of that function right there? You can look at numerator and denominator separate. Can we do anything like you did for that worksheet today? Yeah, what can we do? We can work with the top, right? The top can become x minus 3 and x plus 3. And do you agree the bottom, there's no factoring there, right? There's nothing you can do, right? So it's x plus 3. And so you did that for today on that worksheet. And then I basically told you to simplify if you could, correct? Can we simplify this one? Yes, we can cross this out, correct? And so here's basically what remains afterwards, right? Is that y, that's what f of x is y, same thing, right? Same thing. Equals x minus 3. Do you agree that's all that's left over? Once we cross that off. Well, what that's trying to say is that this graph and that graph are the same, but they can't possibly be. But they are very closely related. They are almost the same graph. But here's what you want to do. Okay, so always look for those that you can cancel out. Once you know, this is very important. Some people don't listen to this part and then they get a bunch wrong later because they try and follow what pattern they perceive to be here. Whatever factor you cross off, which in this case is x plus 3, do you agree with that? You need to set that equal to 0 to find out where the hole is. So you take x plus 3, that's what I crossed off, correct? Set it equal to 0 and solve. That'll tell you the x value of where the hole will be. And what are we going to get if we solve that? Now here's what some people have done in the past. They said, oh, negative 3, that must have come from right there. No, that's not where it came from. It came from setting that factor you crossed off equal to 0. Okay. The reason that's a problem is because that's something that makes the denominator equal 0, which means I'm going to try and divide by 0, which is the one thing in mathematics that is, I think, undefined. Okay. Now, any questions where we've gone so far on this problem? Because we still have to graph it. Okay, but it's very easy to graph it. There's going to be a hole wherever x is -3. You agree that y equals x minus 3 is all that's left over? Well, what we can start to do is let's just graph this line y equals x minus 3. Let's just graph that line. I hope you agree it's a line, right? With a slope of 1 and a y-intercept of -3. See, this is the stuff I always assume is just really easy, and sometimes I'm nervous. All right? So do you agree that means -3, that's your y-intercept, right? And a slope of 1 means up 1 over 1. Up 1 over 1, up 1 over 1. You keep doing it, right? And so then you kind of do that. You can also go down 1 over 1. And so this is the line you would get, correct? Something similar to that? Any disagreements with that? Unfortunately, that right there is the answer to graphing that function. Is that the one we were asked to graph? We were asked to graph that one, so we have to make one small alteration to that line. Nope. Yeah, go to where x equals -3. Where does x equal -3 on my graph? So here's -3 right here. Do you agree with it? Find where is your graph. It's right there. Agreed? And I need to, as I was just said, erase it basically, right? Or if you want to, you can just go like this and put the hole in there, whatever you want to do. Okay? And so just to prove to you that I didn't just make this up, there it is. Now, how could you find out exactly where we've got the x value? Anybody see how you could find out the y value of the hole? Find out where it hits? Okay. How could you figure it out, though, before graphing? Any ideas? Okay, it's whatever you cross out, so we know the x value is -3. How about the y value of the hole? How could you figure it out? Yeah, put -3 in there. Isn't that going to tell you where it should be? I hope that's where I put it. Yep, -3, -6, right? If you put -3 in here, you get -6. Is that where the hole is? Well, yeah. Okay. Is it a hole for this graph? No. Is it one for that graph? Yes. Okay. What I would like you to do is start the next problem. I can tell you right now there is a hole. So go ahead and work on that one. All right, let's take a look. Before doing any work on this problem, I can tell you that x being 4 is a problem. How can you see that x being 4 is a problem before you even start? Makes the denominator 0. So there's for sure some kind of discontinuity there. It's either an asymptote or a hole or something. But our job is to figure out what it is. And what's always the first thing you're supposed to look for? A hole. Now you take a look at the numerator. Is it factor of a hole? Has to multiply to be -12. Add to be, careful, -1. Do such numbers exist? Okay. So here we go. Do you agree that is the numerator factor? I took a little shortcut there. I hope that's okay. All divided by that. So at this point, what we have to decide is, can I get rid of that x minus 4 on the bottom? Can I simplify this and cross it off? And actually, I can, right? So you go ahead and you say, all right, that's gone. So I always like to write what is remaining. This g of x, you can just say, is y equals x plus 3 is still there. Agreed? Did not get crossed off. So we also know there is a hole where Now what you have to do is take whatever it is you just crossed off and set it equal to 0. Because we know that's where the problem is. We know that's a problem number. And that's a problem number, and that is positive 4, correct? But then we already know that was a problem number. We did, but we didn't know what it was. Was it a whole? Was it an asymptote? I don't know. Now we know it's a whole. So now all I have to do is graph y equals x plus 3, which is a line, and put a hole where it's, so it's 4 comma what? Before we graph it, how are you going to figure it out? Well, put 4 here. Can I put 4 in that equation? No. Because you're dividing by 0, you can't substitute it in there. But once you take it out, you can. So it's 4 comma 7, there should be some kind of hole. So I'm guessing if I did this right, I go to 4, 7, and tap, that should be where my graph is. There it is. Okay, and is that the right line? Do I have a y-intercept of 3? There it is. Is the slope 1? Okay. I put 4 in here. Like an XY table kind of thing. And so I put 4 there, and I got 7. Is where the hole had to be. Okay. Any questions?